Welcome back to the Tech Talks Daily Podcast, a place where we demystify complex technologies every day and provide real-world examples of how technology is transforming businesses and reshaping entire industries. But we do all this in a language that everyone can understand. And with the mobile and telco industry historically being dominated by proprietary, closed technologies and vendors, I want to learn more today about how RISC-V is growing in popularity and the mobile industry is adopting openness at a massive scale for the very first time. So ultimately, I want to demystify the world of RISC-V and how it's not only shaping the evolution of 5G, but how it's also redefining the broader mobile landscape. I'll also explore how, just as Linux drove enterprises to embrace open source software, maybe RISC-V could also drive mobile operators and telcos to embrace open approaches to building networks. But before we start today's interview, I just wanted to give a quick mention to our sponsors, because this month the podcast is brought to you by Flipper, which is the #1 marketplace to buy and sell online businesses and startups. So, do you run your own online business? And have you ever considered selling your website, your store, your tech, or your app? Because with world-class combined matching technology, dedicated brokers and end-to-end services, all at the most efficient price, Flipper is making it simple to sell your online business. So to get a free valuation, visit my friends at flipper.com/techtalks, where each month thousands of online business owners exit with Flipper. Again, visit flipper.com/techtalks. So buckle up and hold on tight so I can beam your ears all the way to the US, where Adil Kidwai from EdgeQ is waiting to join us in conversation today about how, for 5G to pay off, organisations actually need the flexibility and customizability that RISC-V delivers, but also how the impact of this shift will extend far beyond 5G and will enable the industry to deliver other innovations that would be lost in a proprietary ecosystem. But enough from me. Let's get him on the podcast now. So, a massive warm welcome to the show. Can you tell the listeners a little about who you are and what you do?
Hi, Neil. Nice meeting with you, and thanks for having me in your show. My name is Adil. I live in Santa Clara, California. I work at a startup called EdgeQ. EdgeQ is a pioneer in the field of 5G infrastructure, wireless, and artificial intelligence. We make silicon and use of RISC-V processor in that silicon to implement 4G and 5G algorithms. I have been at EdgeQ for last a little bit north of 3 years. I'm the head of product management here, and my role is to define the feature set, specifications, schedule, customer interaction, business development. As you can imagine, at a startup, you got to do a lot of stuff. Yeah. That's what I do. Happy to be on your show.
Awesome. Well, it's a pleasure to have you here. And a bit of a tradition we have on the podcast is, before we talk about the great work that you're doing and look towards the future, is take you back in time for a moment. So can you remember where your passion for technology and startups came from, or just a moment that put you on this path you're on today? And ultimately, what is your origin story?
You're taking me back in the memory lane. So,
yeah.
I'm originally from India, from North India. So I always have been kind of very good in mathematics since I was a kid. When I kind of started my undergrad, I started getting more and more interested in physics. But I always was a science person, mathematics, physics, and stuff like that. During my undergrad, I started getting more and more into, device physics and, how the atoms move and transistor. And slowly I moved into the field of, electronics, electrical and electronics engineering. And it started from there. I always was, when I was exposed to the wireless side of the world, I got my first job at Motorola back in 2001. And it always fascinated me how wireless communication works and what are the complications in wireless communication. And it always felt unreal to me that you can transmit signals and waves across from across the ocean. So it started from there, and then I did my graduate studies at UCLA, which is also very big in communications. After that, I joined Intel Corporation. I was lucky to work on a lot of wireless communication technologies. I started with Wi-Fi, then worked on Bluetooth. After that, Intel acquired a company called Infineon Wireless in Munich. I moved to Munich. I used to live in US. I moved to Munich with my family, lived there for 3 years, learned cellular communication for a few years, 3G, 4G, and 5G. Came back to the US and did a small stint in AI. So, I have background in a lot of these technologies, and that's what I assemble all of them together at EdgeQ. And when we talk about the product that EdgeQ is making, you will know why all these technologies matter to EdgeQ.
Love that. And of course, it was all that path that you took there that would eventually lead you to EdgeQ. And for many people listening, it might be the first time they're hearing about you guys for the first time. And yes, you are a leading innovator in 5G systems on a chip. But can you tell me more about the company and the problems you solve with technology?
So EdgeQ was formed in 2018, around April, May timeframe of 2018. So we have been around for a little bit north of 4 years now. It was formed by the founder and the CEO of the company, Vinay Ravuri. What we saw in the market was that there were a lot of companies which were focusing on the client side, the user equipment, as they call the UE side, the cell phones and the computer laptops of the world when it comes to wireless communication. On the infrastructure side, there were not many innovations going on. There were, traditional companies like, Ericsson, Huawei, Nokia. However, we felt that there is a gap in the market which we could fill. At the same time, we were also contemplating on one of the key topics that a lot of people talk about now, but we were thinking about this 4 years ago on how 5G and AI can work together to make the respective technologies better. For example, can AI, artificial intelligence, help 5G? And vice versa, can 5G help artificial intelligence? We were thinking on those lines, and we realized that there is a compelling product that we can make, which will solve some critical problems faced in the wireless infrastructure field. And that is kind of how the journey started of EdgeQ. We have been around, as I mentioned, for a little bit more than 4 years now. We are sampling the solution to our customers. We will be in full mass production by Q2 of 2023.
Excellent. And one of the things I always try and do on this podcast every single day is take a different trending technology and try and demystify it and put it in a language that everyone can understand. And one of the reasons I was excited to get you on the podcast today was ask you to introduce the listeners to RISC-V. Can you introduce everyone listening to that and how it's not only shaping the evolution of 5G, but also redefining the broader mobile landscape?
Let us take a few steps back on, what a processor is, right? What a microprocessor is. Microprocessor is an element which is actually a compute element, right? You give it a task, you give it a task to multiply 2 numbers, you give it a task to divide 2 numbers, add 2 numbers, accumulate numbers. This is pretty much the basic, very, very basic of a microprocessor is. And there are, of course, memory elements, which also play a significant role in the overall efficiency of microprocessors. There are several types of microprocessors in the market, right? There are, x86-based microprocessors, which is pioneered by companies like Intel and AMD. There are ARM-based microprocessors, which are pioneered by a lot of companies, including the Apples and the Qualcomms and the Marvels of the world. The IP is sold by a company called ARM. And then there is a third type of microprocessor that came in the market, and that is RISC-V. Now, the beauty of RISC-V microprocessor is that it allows the user to add micro instructions and therefore change the ISA, the instruction set, right? So you can actually write your own instructions based upon the use of those instructions in the workload. Let's say I'm running an application which is Microsoft Excel, right?
Yeah.
It is a different kind of workload than let's say I'm running an application like MATLAB programming, right? Or let's say I'm running an application, just name an app. You are running that on a microprocessor. 5G requires very different types of mathematical operations, and those mathematical operations are very, very special to signal processing in general. Therefore, one needs a microprocessor which gives the ability to add micro instructions which are innovative and which can help you save power and area. That is the openness that RISC-V offers, and that's why we chose RISC-V processor to implement the 5G algorithms.
And before you came on the podcast today, I was doing a little research, and I was reading how RISC-V's growing popularity is enabling the mobile industry to adopt an openness on a massive scale that we've not seen before. Is that something you can expand on too?
Oh, absolutely. I mean, one of the beauty of RISC-V, as soon as you make the argument that one can write her own micro instructions on the microprocessor, the next argument is that means you can actually implement different types of algorithms as used by the different industry operators on the chip, right? And that leads to an open environment where, let's take an example here, right? A few major operators like the Vodafone or T-Mobile or AT&T or Verizon. Each one of them implement 5G algorithms, at least some part of it, very differently depending upon their user profile. Right? Popular algorithms like channel estimation has a bunch of different ways to implement. Equalization has a bunch of different ways to implement. Using RISC-V as a base technology enables one to open up these algorithms such that different operators can implement those algorithms on the same chip. This is also known as programmability. For example, AT&T can say, you know what, I have a channel estimation algorithm and I want to implement that on your physical layer, 5G physical layer. If the implementation is RISC-V based, then it's very software programmable. Therefore, you can actually change the algorithm on the fly for it to become the algorithm that AT&T prefers. Vice versa, let's say Vodafone comes to us and Verizon comes to us and they want to use a different algorithm. We let them use their own algorithm onto our silicon. That is the beauty of RISC-V, and that is why RISC-V is becoming so popular, because it is programmable, it makes the silicon malleable, and very transformative technology, I would say.
And if we were to look back to our tech past, it almost feels like there's a lot of parallels with how Linux drove enterprises to embracing open source software, with how RISC-V is driving mobile operators and telcos to embrace open approaches, but to building networks. Is that something you agree with? Do you see those parallels? And if you do, what do you think this will mean for the industry moving forward?
Oh, absolutely. This is a very good parallel that you have drawn. I think this is a good example because eventually, I think the 5G and modem algorithms, which historically have been very, very closed, right? When you buy a 5G chip, the algorithms come with it. There are not many examples where somebody will say, buy my chip and use your own algorithm. Moving forward, the industry is becoming more and more open. As we move from 4G to 5G, the feature set has become more and more open. There is a higher and higher degree of interpretation that is happening in 5G feature set, right? It's not as rigid as it used to be. 6G will be even more, which means that if one wants to implement the features as defined in the 5G standard, one can change the algorithms and implement the same feature using a different algorithm, right? This trend is going to continue with 6G and beyond. And I definitely see an industry where these algorithms are all open. You can pick and choose the algorithm that one wants and not get tied to one particular type of implementation which comes with the silicon.
And I'm curious, what keeps you up at night, and how do you keep your curiosity and open-mindedness alive? Because everyone's going to be looking at you to be driving these changes and leveraging the opportunities that RISC-V can offer businesses and individuals alike. But what kind of things motivate you, and equally those problems that keep you up at night? I'm curious on that.
Yeah. I mean, the challenges that this industry is facing, right, particularly on the infrastructure side, right, they are enormous in terms of the cost point, the industry adoption, as well as where the world is heading in terms of the new algorithms that are coming in 6G. 6G is coming to be 6G will offer a lot of new algorithms and new ways to make the wireless communication even more efficient. One of the key, let's say, mantras of EdgeQ is to make sure that the silicon doesn't become the bottleneck in the future, in the sense that the silicon should be fully programmable and malleable, such that different types of algorithms and different types of use cases can be implemented on the same silicon, and there's no need to tape out and get a new silicon if a new algorithm or a new use case comes in, right? So when we look at 5G and going forward, when we look at 6G, one of the key differentiators that EdgeQ provides is to make sure that the silicon becomes kind of a vehicle to implement these algorithms and not the bottleneck. That's what we are driving towards, and that's what keeps us innovating.
And of course, we are at that time of the year where everyone's becoming obsessed with looking towards the trends that are going to dominate the next year. And for a few weeks, at least, we're all going to be incredibly optimistic about what the future holds. So if you were to look into your virtual crystal ball and have a glimpse into the future, can you tell me more about how you see the impact of this shift will extend beyond 5G and maybe even enable the industry to deliver other innovations that would be lost in the historical proprietary ecosystem, for example?
We see clear trends that 5G network is going to fundamentally change as compared to what it was, 3-4 years ago. And this trend will continue towards 6G and whatever G comes beyond that, right?
Yeah.
The network is going to be optimized. The network is going to be more open, where the same hardware can run even multiple operators, right? The network optimization will have reduced bits per hertz cost using converged 5G and AI. We also see that AI is going to play a big part in this optimization that I'm talking about, right? So I think starting from the 5G, packet processing, which is kind of the very, very basics of 5G, how the networks transform and use lesser power using the latest and the greatest architectures that are around, how the network are going to be open source, running the open source software rather than running proprietary software. These are all challenges that we look forward to.
And what about yourselves at EdgeQ? I appreciate you probably can't share too much, but is there anything you can share about on what you're going to be focusing on next year?
Yeah. So as I mentioned, we have been, working on the 5G silicon and the algorithm and making sure it is open and transformable in the coming future. So now we are in the last lap of our productization. We will be in mass production in 2023. 2022 has been pretty much proving our technology in the customer's labs. We have a lot of customer traction, and 2023 is about shipping those silicons and the algorithms in mass units.
Now, some of the biggest names in business, VC funding, and tech have either been guests or listened to this podcast. So I want to see if there's something I can do for you now. And that is that a person that you'd love to have a private breakfast or lunch with, and why? And I'm going to send this out to the universe. Let's see what we can manifest and make happen, because he or she might just listen to this. But who would you go for and why?
Yeah, Neil, unfortunately, I don't think you cannot make it happen. I always wanted to meet Steve Jobs. And the reason is, it always fascinated me how he had such a, great intuitive understanding of what the customers want. I work in an industry where I have to kind of predict the features and the specs of what the customers might be looking for. And I always was amazed at the insights of Steve. I watched a lot of, videos of him, and the way he thought, I thought was phenomenal. So yeah, I think people like me who are in a shoe where we have to, quote unquote, predict the future, could greatly benefit by his wisdom.
I completely agree with you. All I will say is that I am good, but I'm not that good. That's one just outside of my powers. That one, my friend, but a great answer. But for anyone listening that would like to find out more information about EdgeQ, maybe explore some more of the topic we discussed today, find out more information about RISC-V, etc. What's the best starting point for all things EdgeQ?
One can visit our website. The website is edgeq.io. edgeq.io. That is a great resource. We have a lot of educational videos there about what 5G is and what massive MIMO is, what is RISC-V, how AI and 5G converge at mathematical level, what are the use cases. It's a good resource. I believe there are a couple of email IDs listed on our website, so one can always send us an email and find out more about what we're up to.
Fantastic. Well, as I said a few moments ago, I cannot thank you enough for coming on here, not just for talking about RISC-V and how it's not only shaping the evolution of 5G and redefining a broader mobile landscape, but also demystifying the technology, talking about it in a language that everyone can understand, and also sharing your very personal and inspiring story behind all this too. So just thank you for spending the time with me today.
Absolutely, a pleasure. Thanks for having me.
What a great conversation. And I'd love to hear your thoughts about how RISC-V adoption is transforming the mobile industry and what you think that'll mean for 5G and beyond. I cannot thank today's guest enough for coming on here, explaining how EdgeQ is a 5G chipmaker that is leveraging RISC-V architecture to make its tech more open. But we covered a lot in a short amount of time. So as always, email me, techblogwriter@outlook.com. You can connect with me on Twitter, LinkedIn, Instagram, just at Neil C. Hughes. Let's keep this conversation going. I don't have all the answers. I suspect you might have a few of the missing pieces, and I'd love to hear from you. But that's it for today's episode. I've got another great guest lined up tomorrow, but a big thank you for joining me today. And until next time, don't be a stranger.